Hey there, CJ Math students. Go ahead and turn to your packet, page 331. We're going to understand how rewriting expressions today can offer different information. So before we get going, just a quick example of area, right? So pretend I have this rectangle here. It's 3 by 10, right? So the area is equal to 3 times 10, which is 30 units squared, right? However, now let's pretend that I take this same rectangle and divide it up. I'm going to say up top now we've got 8 and 2, and still 3 on the side. There's a couple different expressions I can write to find the area of this. So first we could say, all right, let's do the area of the first rectangle, 3 times 8, plus the area of the second rectangle. I got that 3 times 2 simply because I took this 3 and I made it the same thing on the other side. That's what rectangles are. They have two sides that are matching. The second way we could do this is just say, hey, 3 times the sum of 8 plus 2, because the area of a rectangle is its length times its width, and so if I wanted to find the width, the entire width would still be 10 because I would add those two together, and I would still get 30. Okay? So on page 331, we've got this problem. They're doing a yearbook layout, and you notice they've given you all of this information. You got this section right there has a height of 4. This section right there has a height of 6, so the whole section has a height of 10. Down here, you got a length of 5, a length of 3, so the whole length of 8. So that whole area is 80, right? We'll know if we got it right if we got 80. So Paolo thinks of the area of the page as the product of the total length, right? So we kind of just did that, right? 5 plus 3 there, and 4 plus 6, which is still 8 times 10, which is 80, right? Tamara thinks of the area of the page as the sum of the areas of the photo sections and the list sections. So she's breaking it out. She's saying, hey, I want to find the area of these photo sections right here, and then add it to the area of the list sections, which should still give us the same answer. So for the photo sections, she's saying this first photo is 5 by, if you bring this over, 6. The second photo should still be 5, because that's what it is at the bottom, by 4. So here we have 5 times 4. She did that one right there. And we need to put a 6 in for right there. And then the event list section. So here it's 4 by, what's this bottom number? Well, go all the way down here, 3. And 3 by 6. So if we fill this in, they've already got their 4 and their 6 here. They've already got their length. They need their width here, which is 3. And if you did this math again, it's 5 times 10, 3 times 10, 50 and 30. It still gives you 80. So both are correct, right? Emily thinks the sum of the area as 4 separate sections, right? So she's talking about doing the group photo plus the member list plus the event photo plus the event list. So even a little bit more specific. So you're just taking the area of each of these. So the group photo is right there is 5 times 4. Plus the member list is 3 times 4. Plus the event photo is 5 times 6. Plus the event list is 3 times 6. And if we add these all together, 20 plus 12 plus 30 plus 18, you still get 80. So all are correct. They just give you different types of information. One was total area. Whatever I write down, you write down. Tamara was all about give me the area of the photos versus the lists. And Emily was all about give me the area of each section, right? Whatever I write down, you write down. And before we go on, let's go back to our original example of this, right? So let's pretend this time you don't have all the numbers. So we still have a 3, we have an 8, and this time we have an x. Well, how do I still write an expression for the area of this rectangle? Well, again, I could break it up into saying the area of each rectangle, which is 3 times 8 plus 3 times x, or 3x. Or I could write it as the area of the sum of the lengths, which is 3 times 8 plus x, right? And that's essentially what they're going to ask you to do on 332. So this time we've got a yearbook. We've got some dimensions filled out for us, but we don't have all of the dimensions, right? The first one says, look at the activities and quotation section. So this part right here, and it says, label the diagram to show the combined height. Well, we know that the total height of this thing is 10, right? Now we've got 5 U's there, 6 U's there. So how much is left? Well, to figure that out, let's do 10 minus 6, 4. So this remaining height is 4, right? So if the quotations part is 4 minus x, that total thing minus x, then the activities section simply just has to be x. It's a variable that we don't know. That height literally varies depending on how many activities the student puts in that section. So now we're going to write two different expressions to represent the combined area of activities and quotation section. So just this part of that. So we know that the bottom number is 8, and this side number is 4. So that's one expression, is 8 times 4. The other way we could do it is break it up and be a little bit more specific. And we could say, hey, we're going to do 8 times x, the activities part, plus 8 times 4 minus x, the quotations part, right? This one was total area again, and this one was a little bit more specific. It was the area of each section, right? No matter what, you could still get the same answer. It's just a little bit more specific in what they give you. So for your exit ticket, explain what Teresa's expression tells you versus what Adnan's expression tells you. They're both exactly the same, but Teresa is saying 8 times 4 minus 8x, and Adnan saying 8 times 4 minus x are saying kind of a little bit different things in what their expressions represent. Now, once you're done, move on to your weight graph.